In this topic, you'll see how Windows actually builds a certificate chain, from the leaf to the trusted root, and where things break. We'll walk through real trust errors in browsers, servers, RDP, and ADCS using only built-in Windows tools. So far, you've designed a PKI, deployed ADCS in Azure, issued real certificates, and wired them into IIS, RDP, users, and computers. You've also fixed enrollment failures. Now we're moving to the next layer. Can clients actually build a valid chain, check revocation, and trust your PKI in production? Certificate chain trust is about building a clean path from the server's certificate to a root your system already trusts. If any link in that path is missing, unknown, in the wrong store, or expired, Windows treats the whole chain as untrusted. That's when you get browser not secure messages, RDP prompts, TLS errors, or event log warnings. As you troubleshoot, always ask, is this an enrollment issue or a validation and trust issue? When Windows validates a certificate, it starts by treating that certificate as the end of a chain and asking, who issued this? Using the authority key identifier and issuer name, it searches local and enterprise stores, plus any group policy or AIA locations, to find matching CA certificates. It repeats this process up the hierarchy until it either lands on a trusted root or determines that no complete trusted chain can be built. After Windows builds a candidate chain, it runs a series of sanity checks. Each certificate must be within its valid time window. Every issuing CA must be marked as a CA and allowed to sign other certificates. Key usage and enhanced key usage must support what you're trying to do, like server authentication. And the root has to live in the appropriate trusted root store for that context. Windows separates trust into different stores so it can answer 3 questions: which certificate, at what level, and for whom. Root CAs belong in trusted root. Intermediates go in intermediate certification authorities. Then you choose the scope: local computer, current user, or domain. Many chain failures come from roots or intermediates imported into the wrong store, or installed only for the user when the computer or entire enterprise actually needs them. Imagine an IIS certificate that works fine on your laptop, but shows issuer not trusted on a server. In most cases, the server certificate itself is fine. Instead, the root CA never arrived. The intermediate CA is missing or outdated, or the cert landed in the wrong store. Remember, Windows has separate stores for the user and for local system. A misconfigured group policy can break any of these and cause inconsistent trust. In an enterprise, the root CA's certificate is typically published to Active Directory and pushed to domain machines through group policy. When everything's healthy, clients quietly populate their trusted root and intermediate stores. If policy processing breaks, users just see untrusted errors. The real cause might be DNS, replication, or GPO issues, not a bad certificate. Use tools like GP update source and GP result/TOR to confirm policies are applying. Non-domain machines need a separate trust distribution method. It may help to picture the certificate chain as a physical chain. The leaf certificate is one end, the trusted root is the other. If an intermediate is missing, the chain can't be completed, even though both ends look fine. Some clients will try to download the missing intermediate using the AIA URL, but that's not guaranteed or always fast. The reliable approach is simple. Configure servers to send a full current chain, including every required intermediate. Root CAs define the security boundary for your entire environment. With the correct root in the correct trusted store, clients automatically accept valid chains and your certificates just work. If a required root is missing, applications fail. If a malicious or unapproved root is present, attackers can impersonate anything inside that trust scope. Treat root distribution as a controlled change. Know who owns it, where it's deployed, and avoid ad hoc imports on isolated or non-domain systems. When you're troubleshooting a certificate in Windows, the Certification Path tab is your fastest health check. Open the certificate, switch to Certification Path, and read the status message at the bottom. If it says, cannot be verified up to a trusted certification authority, the chain is broken somewhere. Click each certificate in the path, open its details, and confirm validity and issuer. Fix any warning here before you dive into command line tools. For deeper troubleshooting, export the certificate to a SIR file. Then run certutil, verify webserver.ser. Windows will build the chain, check each issuer, and report whether the chain ends in a trusted root. Focus on the final status and error codes, not every verbose line. Messages like untrusted root, issuer not found, expired certificate, or invalid usage usually point directly to the configuration issue you need to fix. PowerShell gives you a consistent way to inspect and compare certificate trust across servers. With the cert provider, you can browse cert, local machine macstrut, local machine macstrut, and cert local machine, CA, just like folders. Run get child item there, then focus on subject, issuer, thumbprint, and not after. Compare thumbprints between servers to confirm the same roots and intermediates are installed. Once scripted, these checks become repeatable, automated trust validation for your entire environment. When a browser TLS site or RDP session throws a trust error, start by reproducing the error and opening the certificate that was actually presented. Check the full certificate path on the affected client. Then verify whether the required root and intermediates exist in the correct machine or user stores, using certutil if needed. Finally, compare a working and a failing client to pinpoint missing trust and decide whether the fix is local or domain-wide. As you troubleshoot chain trust, think checklist. First, confirm the certificate has a complete chain to a trusted root. Next, verify every root and intermediate is in the correct store and properly distributed to clients. Then prove it with tools like certutil, PowerShell, and certificate path viewers.